All right, the third probability that we're going to look at is actually our theoretical probability rule. So our probability of an event A occurring, right, is the number of outcomes in A divided by the number of all possible outcomes. A list of all possible outcomes is going to be called the sample space. And an event is any collection of outcomes in the sample space. So in other words, what we're looking for, our probability of event A occurring is the number of possible outcomes in the event divided by the number of possible outcomes in the sample space. All right, so we're going to use this rule to calculate these theoretical probabilities in this next example. Reach into a bowl that contains 5 red dice, 3 green dice, and 2 white dice. The dice are well mixed. What is the probability of picking a red die? All right, well, we have 5 red dice, right, divided by the total of our sample space. Right, if we add these up, 5 plus 3 plus 2 is going to give us 10. So our probability of picking a red die out of the bowl is 5 out of 10, which we could reduce to 1/2, which we could write as 0.50, or we could write as 50%. As always, as you're going through the homework, just pay careful attention to rounding and format for answers. Do they want a fraction? Do they want a decimal? Do they want a percent? How many place values are going to be kept? Right, so pay attention to that as you are inputting your answers, as always in this section as well. Right, probability of a green die. Well, there are 3 green dies out of 10, which gives us 0.30 or 30%. A white die, 2 out of 10, reduces to 1 out of 5, which if we divide it out gives us 0.20 or 20%. Right, so again, our probability of an event happening is the number of events, right, the number of outcomes of the event divided by the total number of outcomes in our sample space. We'll look at one more example underneath here, kind of similar, kind of different in a way. Instead of just looking at something a little more simple, we have kind of a more complex setup, but we are still going to be using the same idea here. So roll 2 dice and add the outcomes. Assume each side of the die is equally as likely to appear face up when rolled. What is the probability that the sum, which is S, so we're thinking about the probability of S, of the 2 dice is 7. Right, so the first thing that I did is I went through and I listed out our sample space. Right, so what we see here are the different combinations. So die 1 rolls a 1, then die 2 rolls a 1. Die 1 rolls a 2, and die 2 rolls a 2. Die 1 rolls a 1, die 2 rolls a 3, and so on and so forth. So what we see here is kind of a nicely organized possible outcomes if we're rolling 2 6-sided dice. Right, so what we need to do is we need to find all of the events in this sample space that give us our desired outcome. Our desired outcome is having a sum of 7. Right, so I'm going to go through and circle these. So 1 and 6 have a sum of 7. 2 and 5 have a sum of 7. 3 and 4 have a sum of 7. 4 and 3. Then we have last over here 5 and 2 and 6 and 1. Right, so what we see here is we see all of these different possibilities give us a sum of 7. So we have 6 possible outcomes for our event. And then if we were to add these up, there's 12 in each row times 3 rows. Gives us 36 possible events total. Right, so 6 out of 36. If we wanted to reduce this, we could write this as a reduced fraction of 1/6, or as a decimal, 0.166 repeating, right? Or as a percent, we could round it off to 16.7%. Right, so if you have a more complicated or more involved sample space, don't be afraid to list it out so that way we can take a look at it and then determine the number of outcomes that relate to our event when we're looking at that total sample space.